So, as the last order of business in this welcome lecture, let me go through the course description of the course with you so that you know what's going to happen. So, the content of the course, I've more or less covered this. And when it comes to learning outcome, again, I think I covered most of these bullets here, but there's one thing that I didn't explain to maintain a log documenting the investigation. So this is something that is very important when you work with mathematical experiments, is that when you're doing an experiment, it's like doing an experiment in a lab if you're a physicist or a biologist. And so it's a good idea to adopt some of these practices that people actually use in labs. And one thing that we found to be very useful is to have a kind of a logbook so that you keep track of precisely what experiments you did at what time, what they showed you, which files they're saved in, and so on. So this is something that we're going to require when you do your exercise, the first mandatory exercise. We want you to make a log, and we of course will tell you how we think you should organize such a thing. The rest, I guess, is roughly something that you can derive from the list of chapters that I went through with you. And then the program is 4 lectures, 4 problem sessions, and 4 computer labs per week for 7 weeks. The lectures are essentially me saying something from going over examples, going over theory. This will be fairly traditional. I will use Blackboard and Beamer and so on. So I found that these lectures, even though it's a highly non-standard course, I try to make the lectures as standard as possible because I think it's actually a very reasonable way of going over this non-standard material. But I think it's safe to say that the lectures are much less important in a course of this nature than for most math courses. They to be a little bit crude, there's a lot of things that you just can't learn from listening to me or looking in the book. You just need to try your hand at making experiments. So this is really the rest of the course is focused on this. So we will have 4 hours of problem sessions with TA Dimitrios. And this will be, you get a list, like a weekly list of problems taken from the book. Some of them will be fairly straightforward, others will be something that needs some programming to address. And of course the purpose of this is to get you used to producing experiments in a small scale before you're doing the real sort of large scale experiments. And then we have computer labs with a Maple TA, Rege. So the point of the computer lab is this is a place or more a time where you can show up with your own computer and work on the exercises or the mandatory projects that you need to hand in. And then you can get help, because the experience I have is it's not a very good idea that I explain at length how to do things in Maple. We'll just do a quick introduction and then we'll let you start writing programs because that's the way you learn it. But of course you will run into problems, there will be frustrations along the way, and then the idea is that you can very easily get help at the computer labs with various problems in Maple, making the program work, making Maple understand what you want it to do, and so on. So this is a very important part of your learning process is, of course, to master Maple somehow. And we just think that instead of showing you how it's done, it's better that you just try it, and then whenever you get stuck, we'll try to get you help quickly. So to pass the course, there are three components. So there's two assignments. The first assignment is due on December 9. This is a fairly moderately sized assignment, which is going to be individual, so you have to do this individually. And so it's a small experiment, and you'll be guided fairly with quite a lot of detail with the description of the assignment that I will publish the second Monday of the course. And then the other assignment is a bigger assignment that you do in groups. These assignments you choose from a catalog of problems, so I will provide a catalog of interesting problems. These are problems that are open in the sense that they address various problems that I don't know the complete answer to. So it's, in a sense, it's an honest mathematical experiment that you're asked to do. And the idea is that you choose a project that appeals to you, and then you work on that in small groups, groups of 2 to 3 people, perhaps 4 if it's difficult to make a good division of you. And then you hand this in. You hand this in, I believe, on January 17. And then we will give you feedback on what you hand in on paper. And then you have an oral exam, which is now individual. So individually you present the results of your second assignment. And you will have the feedback from us before you go to the exam. So at the exam, which is a 30-minute exam with no preparation time, you will then give a short presentation of the experiments you did and your conclusions from the experiments. And then we're going to ask questions, so there'll be some sort of a dialogue, and then we give you a grade. So that's how the course is assessed. So I guess that pretty much concludes what I wanted to say this for the first day of the course. And so the program for the long day of this week is Maple, how to use Maple to write programs. And then in the second week, where I'll be back, we'll be talking about 2 different kinds of writing programs, the iteration approach and the recursion approach. So, see you then.